Alright, this is the video for unit topic 3.1, position time graphs. So this is on unit 3, and this is on unit 3, motion graphs. So the question here says, the velocity of the car 1 is 10 meters per second, and the velocity of car 2 is negative 10 meters per second. The question says, well, is one car faster than the other, or are both cars traveling at the same speed? And explain. Now, what you have to realize in physics, right, and we say this all the time, well, I say it all the time, rather, is that the negative sign here, right, the negative sign is essentially just the opposite direction, right? So the negative sign indicates the opposite direction of the positive. And while the opposite direction of the positive, right, so let's say we say that the positive direction is east, well, the negative direction just means the west, right? So it's we can have one car that's traveling at 10 meters per second to the right, and we can also have the second car traveling at 10 meters per second, but it's going to the left. So we can say that the velocity of the second car is negative 10 meters per second. The car is traveling to the left. Right, the car is traveling to the left. So here we get to something called the position time graph, right? So because that's what this topic is on, right? That's our unit, a position time graph. And a position time graph, essentially what it is that on the y-axis you have something called position. Now sometimes it'll be called displacement or distance, right? So those are the other two alternative names. And on the x-axis, you have something called time, right? So your time is going to be on the x-axis, and the y-axis will be your position. So essentially what this is saying, this graph is saying, at a time of 0 seconds, right? At a time of 0 seconds, I'm at a position of 0 meters, right? So this is 0. At a time of 1 second, I'm at a position of 4 meters, right? So I don't know, at 1 second later, I'm at a position of 4 meters. And at 2 seconds, right? At 2 seconds, I'm now at a position of 8 meters. And that's what this graph is saying. And so from 1 to 2 seconds, well, I'm going this way and this way. And I end up at 8 meters. And that's a position time graph. That's right. That's a position time graph. So the first question here, or rather, let's actually go here. Go here. So this is a simulation, and it shows you the motion of a person, right? It graphs you the motion of a person. So this person is standing on a track, right? You can see that though the person in the middle here is at a position of 0 meters. And I want to make him have a velocity, right? I'm going to give this guy a velocity of 2 meters per second. So every second he's going to travel 2 meters. So I'm playing the simulation, and he gets to 2 seconds at around 1 second, right? So you can see that we're at 1 second. Well, let me just increase it to 2 seconds. So at 2 seconds, you see that the man is at a position of 4 meters, right? So you can see that, let's actually take a screenshot of this, and let's go over here. So you do see that, well, at a time of 2 seconds, right? At a time of 2 seconds, which is what my x-axis is, right? At a time of 2 seconds, this person is at a position of 4 meters, which is why the line stops here, right? Because this is 4. This is 4 over here. This is 4. Now, when I continue playing, right? So we get to 4 seconds here. Right? And at 4 seconds, you'll see that, well, my graph at 4 seconds, which is on my x-axis, my graph at 4 seconds, well, I'm at a position of 8 meters as the man is. So I'm in a position of 8 meters there at a time of 4 seconds. So essentially what the graph is saying, right, the graph tracks motion, right? It tracks the person's position over time. At 2 seconds, his position was at 4 meters. And at 4 seconds, his position was at 8 meters, right? So this is his position. Now, what would the graph look like if, I don't know, he just stands still. He just stood still, right? So uh let's say this man has no more velocity, right? So he's just standing still now. What would the graph look like? Well, if he's standing still, he's going to stay at a position of 8 meters. Right? He's going to stay there, which is what you should see, right? So his position is going to stay at 8 meters. Now, now let's say the man has a negative velocity now, right? And the man having a negative velocity means he was walking back to the other side. Well, what would my graph look like? Right, so here at at a time of, at 5 meters, right? At 5 meters at around 12 seconds, you'll see that the graph, the line reaches 5 meters, right? So this person is at 5 meters. It's almost 12 seconds. So if you look at the x-axis, you're almost at 12. And you'll see that the line reaches a position of 5 meters, which is where he's at right now. So we'll continue the simulation. And now at a time of around 14 seconds, he's back at 0, which is what this line depicts as well. So he's back at 0. And now he goes past 0, and now he has a negative position, right? So he's now at -5 at around 16 seconds. So that's essentially what a position time graph represents. So let's go for these practice problems. Let's go for these practice problems. So the first question says calculate the distance traveled between 0 and 2 seconds, right? Calculate the distance traveled between 0 and 2 seconds. So you'll see that on the y-axis you have your position, right? Displacement. Well, at 0 meters, at 0 seconds, I'm at a position of 0 meters. At 2 seconds, I'm at a position of 8 meters, right? So I'm essentially going from 0 to 8. I traveled 8 meters. The second question says calculate the distance traveled between 0 and 4 seconds. 0 and 4 seconds. So at 0 seconds, you're at 0 meters. At 4 seconds, I'm at 8 meters. So, well, I just traveled the same distance. I didn't move anywhere from 2 to 4 seconds. I just stayed there. I just stayed there. So I didn't move. The third question says calculate the distance traveled between 0 and 8 seconds. Right? So at 0, I'm at 0 meters. And I'm at 8 seconds, I'm also at 0 meters. But the question wants total distance traveled. The thing here you have to keep in mind is that, well, from 0 to 2 seconds, I traveled 8 meters, right? So I traveled 8 meters. But then from 4 to 8 seconds, right? From 4 to 8 seconds, 4 to 8 seconds, I traveled another 8 meters, right? From 4 to 8 seconds, I traveled from 8 to 0. So in total here, my total distance traveled would be 16 meters. That would be my total distance traveled. Right, because I'm going from the first 2 seconds, I'm going to the right 8 meters. But then from 4 to 8 seconds, I'm going back to where I started. I traveled another 8 meters. That gives me 16. The fourth question says calculate displacement at 8 seconds. Something you have to remember here is that displacement means how far you are from your original location. Right, if I ended at 0 meters, right, at 8 seconds I ended at 0 meters, and at 0 seconds I started at 0 meters. So essentially, if I end back at the same place I started, well, my displacement here would be 0. I'm back where I started. That is the definition of displacement. Displacement is how far you are from your original location. Getting rid of that. So now we have this, right? So we're done with interpreting slope. Let's now, or rather, interpreting position time graphs. But now let's talk about the slope of a position time graph. In math, you're taught that, well, my slope is my change in y, right? My change in y over my change in x. So essentially, in math class, you guys should have learned. Let's actually decrease the size here. You should have learned that, well, uh, it's essentially y2 minus y1 over x2 minus x1, right? And it's essentially your change in y over your change in x. How much your y changed and how much your x changed. So what's on the y-axis for this position time graph, right? So the y-axis tells you that, well, that's displacement, d, and you measured in meters. The unit you measured is in meters. And on your x-axis here, on your x-axis, you have time. And the x-axis is measured in, well, time is measured in seconds. So essentially your slope is saying that, well, it's d over t, which is meters per second. And if you recognize what meters per second is, like the unit meters per second is my velocity. So we can say that, well, the slope of a position time graph gives us our velocity. And this is an assumption that we can only make for position time graphs. We can't really make that same assumption for any other graph. So we're going to take a look at this question, right? So we're going to take a look at this question. First question to say is, calculate the velocity between 0 and 2 seconds. Well, again, to calculate the velocity, we need to look at our slope. So our slope here is change in y over change in x. Right, so from 0 to 2 seconds, how much did my y change, right? So I ended up at 8. I started at 0. How much did my y change? My y changed by 8 meters. What about my x? From 0 to 2 seconds, right? I ended at 2. I started at 0. Well, my time is 2, right? My change in x is 2 seconds. And I get 4 meters per second. Calculate the velocity between 2 and 4 seconds. So we're going to do the same exact thing. Right, we're going to do the same exact thing here. We're going from 2 to 4 seconds. So let me erase this. So we're going from a position of 2 to 4 seconds here. Right, so we're going from 2 to 4 seconds. You'll see that at 2 seconds, my position is 8. At 4 seconds, my position is still 8. So my change in y here is 0. And my change in x, while I'm going from 2 to 4, my change in x is 2. And so my answer here is 0 meters per second. So now let's talk about this one. So you're going from 0 to 4 seconds, right? So calculate the velocity between 0 and 4 seconds. So we end there, we start here. So what's my change in y, right? So initially I start at 0, I end at 8. So my change in y is 8. What about my change in x? Well, I start at 0, I end at 4. My change in x here is 4, right? I went 4 this way. So my answer here is 2 meters per second. We go to the next question. They wanted to calculate the velocity between 4 and 8 seconds. Right, 4 and 8 seconds. So we start here, we end here. My change in y, right? My change in y over change in x. 8 to 0, right? I'm going from 8 to 0. I start at 8, I end at 0. Well, I went down. My change in y is -8. It's actually, I don't know what the hell happened here, but it's -8. Right? I'm going down that. So my change in y here is -8. My change in x going from 4 to 8 is 4. So my answer here is -2 meters per second. And finally, the last question. Calculate the change of velocity, or rather from 0 to 8 seconds. So I start at 0, I end at 8, right? So calculate velocity between 0 and 8. Your initial y position is 0, your final y position is also 0. So my change in y is 0. I end up back where I started. My change in x is 8. I went from 0 to 8. So my answer here is 0. All right, that is the lesson. That is the lesson.